Hello, this luckiest maths teacher in the world. Thank you so much for watching as we go through Venn diagrams. Now, this is part of our section on probability because Venn diagrams can be a useful tool to help us find the probability of events. So let's look at what a Venn diagram is. So what we have is we just have a box like this and we have two circles that are overlapping. So each of these circles represents a set. A set is just a collection of objects. It could be a category that we're talking about. They could be anything. So set A and B is what we usually call them. Set A could be, all the people that were born in Australia. B could be all the people with blue eyes or something. What we are hoping to achieve with a Venn diagram is a way to display the number of elements. In this case, if I was talking about people, it'd be the number of people in each category. And that will allow us to calculate probabilities nice and easy. So when we have Venn diagrams, there should be four numbers. So there's a number here for how many people or how many elements are in neither category. So this is all the elements that are not in A and also not in B. Then we need a number to tell us how many are in A but not in B, how many are in both, and how many are in the second category but not the first. So let's look at an example. So let's say that we're going to talk about all of the numbers less than 20. So this here, this Greek letter epsilon, that's actually telling us about our universe. It's telling us all of the objects that we're considering. So in this box, I'm going to place somewhere all of the integers less than or equal to 20. So the numbers 1 to 20, including 1 and 20. I'm going to put them somewhere in this diagram. So let's let A be prime numbers. So obviously we're talking about prime numbers less than or equal to 20, and B will be the set of even numbers less than or equal to 20. So I'm going to take each of the numbers 1 to 20 inclusive, and I'm going to write it somewhere in this Venn diagram. Okay, so let's look at the number 1. So that is not prime and it is not even. So I'm going to put it out here. So 2 is even and prime, so it's going to go in the middle. So then if we look, we have 3, so that's obviously prime and not even, so that goes in A but not B, and then we have numbers like 4, 6, 8, 10, 12, 14, 16, 18, and 20. So all of those numbers are in B only because they are even, but they're not prime. So the other numbers that would go in A, 3 is a prime number, we obviously have 5, 7, 11, 13, 17, and 19. All of those numbers are prime but not even. And then there's still some numbers that we haven't listed, so they're numbers that are not prime and not even. So if we look at numbers like 9, that's obviously not prime, it's also not even. And number 15 as well is not prime, not even. Okay? So a quick count will tell us that I have listed all the numbers between 1 and 20 inclusive. But this, there's heaps of numbers there and it's not really helpful to us. So instead of writing all these numbers in their correct set, what I can do is just write how many are in each set. So let's draw another Venn diagram that represents the same information. So I have A, and remember that's all prime numbers. B is the set of even numbers. So there is just one number that is both in A and B, that is prime and even. There were 9 numbers, simple count can tell us that. 9 numbers that are even but not prime, that are in B but not A. There are 7 numbers that are in A but not B, so they are all the numbers that are prime and not even. And there were 3 numbers outside these sets that are not in A and not B. So what we've done is we've taken 2 categories, prime numbers and even numbers, and we've come up with a way to display very simply how many numbers are in each category, how many numbers are in both, how many are in neither. And this is what we need to do to help us calculate probabilities. Because if I were to ask you questions about, the probability of anything, you need to know how many ways it can occur, and you need to know how many outcomes in total. And this tells us how many ways it can occur. So let's look at an example. So let's say I pick a number between 1 and 20 inclusive. I pick one randomly, and I want to know the probability that that number's even. Now, I know you didn't need the Venn diagram to tell you what this probability is, but I just want to show you how it works. So even is B. So we take all the elements in B. We have to include this one in the middle because it is in B. It's also in A, but it's in B as well. So there are 10 elements in total out of 20. So the probability is just a half. Nothing groundbreaking there. You would have been able to do this without a Venn diagram. But what if I said to you that I want you to find, say, the probability that the number I pick is not prime, okay? So that's what that little dash at the end means, not prime. So remember, A is prime numbers. So I'm saying I want all of the numbers that are not in this circle. So there are 9 such numbers that are in B only and 3 that are in neither A nor B. So there are 12 numbers in total that are not prime. And rather than, going through and saying, is this number prime, is this number not prime, it's really easy to tell how many from the Venn diagram. So the probability the number I pick is not prime is 12 over 20, which is 3 over 5. This is really good at helping us answer and or questions. So what is the probability that I pick a number that is even or prime? Now, as I explained in a previous video, I want you to assume every time I say or, I mean inclusive. So when I say probability of even or prime, I mean the probability the number is even, is prime, or is both. So we can get that from the Venn diagram. All the numbers that are even or prime, one or the other or both, were all the numbers inside the circles. All of these numbers inside the circles are even or prime or both. So the total number of them is 7 plus 1 plus 9, which is 17. So I have a 17 over 20 probability, or 0.85, that I pick a number that is either even or prime. That would have been a hard question to answer without the Venn diagram. Let's say I want to know the probability that I pick a number that is even and prime. So it has to be both even and prime. So we can see from the Venn diagram there is one number that is both out of 20. So it's just 1 over 20. So what is the probability that the number I pick is even and not prime? So again, and means it has to be both. So I can get that from my Venn diagram nice and easily. So even but not prime, so means it's in B because it's even, and it's not in A because it's not prime. So if I go to my Venn diagram, I'm talking about these numbers here. There are 9 numbers that are even and not prime out of 20 in total. So the Venn diagram has made our probability calculations much simpler. All right, thank you so much for watching. This has been the luckiest maths teacher in the world. Have a great day.